Hi, Struppi here. I've been thinking about something with regards to synergetics and spherical thinking, which has to do with the way that we conceive everything, or misconceive perhaps, because you see, the way that the civilized mind looks at the world, all we ever see everywhere is compression. I mean, yes, we do notice sometimes there's tension here and there, but in general, if we see a phenomenon in nature or universe, we tend to think of it in terms of compression, which is curious. I mean, it's related to why we still build our constructs that we call houses out of vast amounts of stone or sand or concrete or the likes, all one building block set upon the next, taking many parts to make something which appears to be a whole in the end, until, you know, the ground shakes and it turns out it's just been an agglomeration of parts and something was missing, which is the tension of relationship. Now, with that in mind, in synergetics, you know, we often speak of tensecrities. I'm sitting on one right now, and tensecrity is the integrity of tension, tensional integrity, which is something that constitutes all bodies of space-time. You see, within myself, there is an organ called the fascia, which is the organ of shape. It's a complex network of filaments and fibers that are livingly organizing the shape of my body as they have grown in, around, and through all of my organs while I was growing in my mother's womb. They move through my bones, through all my capillaries, around all inner and outer organs, even just beneath the skin. And it's one organ which gives us our surface tension, which is our equivalent to what we call gravity in a cosmic context. You see, even on the water we find superficial or surface tension, which is the same thing as gravity. It's the innate sense of gravity of the water. And you know, we find that in all of us, all the time. But we are so focused on thinking in compression and conflict that we think we need to push our will through the wall, when there is no member of our body that is able to push. If we are pushing, if I'm pushing here, it is because I'm tensioning muscles here. Because all muscles in my body are only able to tense, to pull, not to push. And in tensegrity, we often speak of two kinds of behavior, basically, which is on one hand tension and on the other compression. And usually, classically, a tensegrity is described, you know, most of those that are popular are what I would call exotensegrities, where you have a web of fibers or ropes going around a set of compression members, as they're called, as in this case, where we have beads as the so-called compression members and a web of tension that goes through them, triangulating the outside and the inside of them. That's not a classical tensegrity, mind you. Alright, so that is usually the idea, those two things. Either you're tending to tension or you're being compressed. in these systems. However, we also know of precession in synergetics, and precession, I've already spoken about that at length in another video. Precession is the generalized principle of interplay of moving bodies, where whenever that happens, that we have that kind of interplay between two or more, we find there is an angular offset of 90 degrees, which is originally where the right angle comes from, where it originates from, even though that is a completely different understanding or sense of right angleness than the one that we have in general, because the general sense of right angles is, well, it's the static angle of static balance when nothing is moving because all is normalized. And being normalized is really a state of constant fear, the fear of separation, because we're not allowed to actually engage in the relationship of tension between one another. So yeah, one example, a very obvious example of precession is when you have let me get that one. Oops, sorry for the noise. I got the mic on my things here. So orbiting is precession at play, because if I am one moving body here and I'm holding on to this line that connects to the heart of this sphere, as I'm spinning this one around, you see how it wants to continue in a large arc around the next bigger sphere, which would be Earth in this context. But as I'm holding on to that relationship, I am constantly redirecting this by a right angle. See? Like that. Always. And this is something we also find, as Bucky pointed out, in the organic world of the bees and the flowers, where the whole organism operates by having the flowers produce all the good stuff for the bees, and the bees go into the flower like this, and they are collecting the pollen like that. Same thing. But crucially, there is one realm of precession that is oftentimes overlooked, which has to do with the fact that I cannot pull a line or a rope. Well, I cannot push it straight. That's what I wanted to say. I was just looking for a line here. Let me see, where is the end here? The bitter end of this line. So you see, if I was to try to get this straight, there is no use in pushing. If I push the line, it will just fold on itself or something like that. However, the moment I pull on it, it straightens. So a straight line is a line under tension. And it's still going like this, you know. This line is still made up of strands, of which again are made of yarns, made of fibers, and it's always some move this way, some the next level of frequency that way, then this way, then that way. And that's how we get to this line. And what we find is not so much, we can't really see it on this line because it's a very strong one, but if I were to take a rubber and pull on that, you would see how the moment I put tension in this direction, it tightens in this way. It goes together this way as I pull that way. It's pulling together this way while being pulled that way, which is precession. And notice how it's all pulling, though. We call what happens in this direction as we pull that way, we call that compression. But that is a misnomer, I think, because this is tension redirected that way. On the other hand, if we were to push on the rubber, if it's a large piece of rubber, then it would tend to bulge. If we push it this way, it would tend to bulge that way, all right? Which again, by putting tension in here, it's redirecting the tension out there. But that's a weird concept, right? How can it be tensing outwards? But that's what I want to speak about, because I think that's the case. And I think if we were to look at any phenomenon in the natural world of universe, we would probably be able to figure out a way of reconsidering what happens in the terms of compression and figuring out how it is actually tension. And the big example that I want to bring up, which is why I speak of this in the first place, is that I think the same is happening with the light of the sun, for instance, or any star, pick any of them, because we think of this process of the sun shining, again, in terms of compression. We think of the star being under pressure, and the pressure being released outwards by the explosion that we call sunshine. But I wonder if it isn't actually the case that the so-called vacuum of space, so the omni-interaccommodative embrace that is universe, which tends to be a little less dense mostly, except for these places where gravity has pulled together a star or a planet. This embrace of the universe around it is actually, I think, pulling on the star. And it's pulling out the light, it's pulling out the radiation. So here is a model of that for clarity's sake. You see, this is an 8-ice right now, which has a nucleus in the middle in this case. And consider this the star the moment before it ignites, okay? So it's still very much, maybe it's a bit like our giant gas planets in the solar system. I guess it really is a question of how big do they become, and once they cross a threshold, fusion happens inside them and they ignite. And as they do, look at that membrane, okay? I'm gonna ignite this star and it unfolds this membrane, which goes out omnidirectionally in a sphere, all right? And we don't tend to think of it that way. I think we have this perspective on the stars, on the sun, as, yeah, there's that ball of fire in the middle of the solar system, at the center of it, and this ball of fire is, when we think of the light that has arrived at our place, we think of it as being almost parallel rays of light, because it's such a vast distance that the light waves have become something where we consider the wavefront to be a plane, which is really just a very weird kind of perspective if you think of it, because what really has gone on is, from the moment of ignition, the light of the sun has been drawn out by that which we call the vacuum. It's been drawn out omnidirectionally in a sphere. So what we see when we look there is the sphere as it is now of the sun, and it's got a heliosphere and corona and all these kinds of membranes that mark the boundary between their inside and their outside. But what we do not see is the extending sphere of light around that star. Why? Well, because the only way we can see the light is looking right at its center of origin, along the radius of that sphere. That's where we can see the light. What we do not see is at that angle to the star, circumferential. We don't see that aspect of the light, but we feel it because what we call it is gravity. All right, so we're in that field of gravity there, and we're passing along these lines, which aren't perfect circles, of course, because the system of interplay that we're partaking in as the solar system is made up of so many moving bodies that have all influence on one another. It's one complex system. But if it were only just one star and one planet, it would be probably rather a very circular orbit. So what is the idea with this? Well, you see, consider the ongoing shining of that star from the moment it was born to the moment that it passes. We find a growing sphere of sunlight or starlight extending from that center, that point of origin, in all directions. And if we're seeing a star in the night sky, it might be millions of light years away, which is to say that the radius of that sphere that we're partaking in is that far. So the star has already at least grown to that size. We do not, however, again, see any of the light at any other angle than the radial angle. Which leads us to the understanding that, well, the night sky, what we call the vacuum of space, that is actually, well, we don't call the night sky the vacuum of space. We call what we call space the vacuum of space, which is funny because we're in the middle of it, relatively speaking. But this supposed empty space is full of light. It's utterly full of light. There's no place in it where you find darkness. Maybe at a black hole, but, well, we can't really look into it, so maybe inside of it it's just blindingly light. But the thought about this is really that, you could think of that supposed vacuum actually as a high-frequency system of space-time, which is, organized in a certain kind of wave geometry, which is the closest drawing of spheres, or the isotropic vector matrix, or whatever you want to call that, which is the coordinate system that we're using and thinking in the spherical thinking of synergetics. This is the nuclear system of that. And you see, this is a structure that is extending everywhere throughout that supposed darkness. And it's this electromagnetic radiation. It's not just a radiation, though, because when you have radiation, which is this direction, you also have embration, well, correlation or circumferentiation, which is gravity. We have that everywhere. We can't defy it, even though people have tried. We can't ignore it. It's just everywhere, and it's embracing everybody with everybody. Well, thinking of it that way, we figure that that supposed vacuum is full of structure. It's just the medium of the structure is electromagnetic waves, which aren't, they aren't territorial. They don't say, oh, there's a planet coming, we're not going to let it pass. It just moves through it as the fish moves through the waters. So we find ourselves not only at the heart of the air ocean of our kinship Earth, but also of the light ocean that is so seemingly dark of this vast universe of ours. And one last thought on that is about the shadows. So the way I see it, I spoke to this in different videos, but space-time is spherical and it contains the time. Like the time is the relationship between the bodies of space-time. What we find within the bodies is the pasts, what we find between the bodies is the present, and what we find behind the bodies, relatively speaking, is the futures. And everything is constantly in motion, which is the so-called now. And as a planet, for instance, moves through the light sphere of the sun, it casts a shadow, which, as the light sphere emanates, traces the direction, the travel of that planet. And as that happens, it remembers the presence of the planet. And that's where I want to leave it for now. Just some food for thoughts. Have a good time.